Right. Great. Are gonna check out some massive terrain representation tonight on this live stream and see how this actually works with different kinds of data or different websites that provide this kind of data. And this is not the most robust version of doing this, but it is a way to start to visualize and understand what massive terrains can look like and what we can use publicly. Also, I will be specifically using Rhino on this. So if you want to use Rhino, you can either use the free trial or buy it. It's got a good pricing model, all that kind of stuff. With that said, we have Rhino here. And also, what we are going to compare is the difference between two different resources. And these resources are these. So we have the terrain.party, and we have the cities skyline map generator. And now both of these kind of exist in a similar state and they behave slightly differently than each other. With that said, what I want to acknowledge before we move on is that this is based on a tutorial I ran previously where we looked at how to create something in Rhino and then bring it into a larger context. And we are using a very specific means, and that is height maps. Height maps allow us to take the data involved in mapping terrain, topography, landscapes, whatever you want to call it, and reducing it to a raster-based information set that Rhino can then understand. With that said, once we create those terrains, they might not always look perfect, but they are massive. I am very interested in doing a follow-up on this about whether or not this plays well with some of the Unreal game engines and virtualization. Twinmotion, for example, would be a great application for this. We're going to take a second to just check on how things are going. And now we are gonna be off. What I want to share with us is what we have going on here. And what we see here, Rhino's in the background, but we're looking at the difference between terrain.party, which has been used in the past. I like this interface, and that's on the left-hand side, and on the right-hand side, we have this heightmaps.skydark. A lot of students in my classes have said that this is a great resource for the things we're doing. Each of these resources are good. We're going to leave terrain.party alone for now because the videos I've done before have really helped out with that. And we're going to focus on the heightmaps.skydark.pl cities.skylines map generator. And what we're looking for as we expand this is we're looking for a place to get a location. So we could zoom in. For example, I am currently over here in Massachusetts, right? Somewhere in Boston. I'm not going to get my exact location, but I'm somewhere over there. So we have a location defined. And what we need to do is we need to go to the settings, and we need to make sure that this tool actually generates, refreshes, and gets that information. So it's not going to actually work unless you open this up and make sure you get the refresh on it. This is going to give you a bunch of information that is available there, which is very helpful. What I'm actually going to do is I'm going to zoom back over here because I want to start. I've been watching a bunch of documentaries about Africa, and we are going to go to, where did I want to go? There we go. We want to go here, and we want to go down into this area because there's some really interesting topography changes around this area here. Right at this divide. Yeah. And actually what I'm going to do is I want to make a comparison. So this is very interestingly the Mafadi, I don't know how to pronounce it. I'm sorry if I mistakenly pronounced it, but it is one of the areas in this area of Africa that has a huge elevational difference, which is why I'm using it to showcase this elevational difference. It's very expansive, right? It has these huge coastlines, and it's pretty cool. Also, if we just kind of leave that alone for now, what we're going to do is we're going to visualize this in Rhino. So now let's center it right there. So I'm just clicking and dragging, center it there. And I am going to, let's refresh this. Because this is going to give us the minimum height and the maximum height in the area that I've defined. I have 17.28 kilometers defined as my map size, which I think is okay for now. And my base level is 0, height scale. These are important things to note. Also important to note is the streams, the markers, and the grids. And the next thing I'm going to do is we're going to try this. So on the left-hand side, we're going to download the PNG map. We're going to see sometimes these web-based interfaces don't always work. We have a height map, which we are going to open. And sadly, no, that did not work. Something went wrong. So what I did is I opened that height map, and all I get is a blank white thing. And so what I need to do here is I need to refresh this to auto, let it regenerate that map. And then we're going to download this height map again. And we're going to give it another try. And now we get that map. I'm not sure exactly why that happens in that way, but it does happen in that way if you don't get the auto and the download. Now, what I'm going to do is I'm going to turn off the markers in the grid. I'm going to refresh this map, and we're going to look at that difference there. Remember that the grids on this map are not going to be helpful for us because the height map, when we bring it into Rhino, is not going to make sense at all. It's actually going to specifically change how that height map is. You're going to see those grid lines in the height map definition of the Rhino file. And so now we're going to download the PNG height map file one more time. And we're going to open that. And there we go. So this is the grayscale values of the heights of that area. And what we are looking at here in terms of what I believe we are looking at is that we are looking at the area that is mapped out throughout the entire kind of gray area. But there is a definition between, I think, the accuracy of the green and the gray and the highlighted blue, where they're pulling that data from. So we could get into the intricacies of that, or we're going to leave that alone for a second. And we're going to switch over to Rhino. And when we switch over to Rhino, here we go. We have a clean Rhino file. What we're going to use is the height field. And the height field is a very helpful command. And I'm just going to make this a little bit bigger here so you guys can see height field. This is what we are talking about. It's a height field command. And the height field command is going to give us the ability to bring in a black and white version of terrain. And when we do this, we get that ability. So you can see some of the maps I downloaded, and this one didn't work. This one has grid lines, which we don't want. And this one does not have the grid lines. This one is very helpful and will be the most useful for what we're doing. Now I've brought this in. Let's see, we auto-saved. We want the first corner on this. Actually, I want the first corner to be 0, 0, 0, but I am realizing that I might need to concentrate on something else, which is the units of what I'm working in before I do this. Because if I do 0, 0, 0, 0, it's asking me for a length. I don't know what length Rhino thinks I'm at. So I need to set my units. And going back to our map here, we're using primarily kilometers as our units, which is what I'm going to use in this. So let's switch this from inches to kilometers right there. We're not going to worry about the tolerances because we just need kilometers. And we're going to type in height field one more time. And again, we are using height field as our as the primary command there. So with that selected, we're going to select our, with that command initiated, we're going to select that. We'll hit open. Now we're going to type, it's asking us for the first corner, which will be 0, 0, 0, always the best place to start. And in this case, going back to our map that we created, we want the map size to be 17.28 kilometers. So it's asking for a length here, which means that we do want this to be 17.28 kilometers, and we'll hit enter. Now we have a bunch of different options, and our options are the number of sample points, the height, and how we want the objects, create objects by. And this is very specific. Be very careful, because if you supply something like 1,000, the difference between 1,000 and 100 sample points is very important. When you have 100 sample points, you're spreading those out only within 100 different points within that area. You have 1,000 sample points, you're going to spread them out in 1,000 different points within that area, and you're going to have more data to deal with. So if your computer is not prepared to computationally and through its hardware figure out the black and white pixel data of that information and develop that on a scale, it's not going to work. I'm going to go with 1,000 because I want to show what this looks like. And the height is actually going to be defined by the max height here. Now, there's a question of whether or not we should subtract the min height from the max height. I'm not going to do that, but what I am going to do is I'm going to convert 3.338.1 meters to kilometers. And to do that, we can do this just to be sure. Like, why not? So meters to kilometers, which is 3.3381. Some of you might be able to do that in your head. Some of you might need that little conversion. All right, we are going to use a mesh with vertex at sample location. And there are 3 different options here, which we will look at each of them. We're going to hit OK, and we have created a thing. We use a zoom all extents, and I'm going to switch this to Arctic because Arctic is a helpful viewing method for this. Now you'll notice that there's a bit of lag happening on my computer as I'm working on this, and that is because it is a lot of information. And to some degree, I am slightly regretting, oh, I did not use Arctic, I used Artistic. I wanted Arctic, there we go. But we do see a version of this terrain, which I think is pretty cool. And let's turn all of these to Arctic. Don't do that. Down on board, zoom all extents. There we go. All right. Now, does that look like it compares? I think it does. Right? It looks like a fairly good comparison. And you know what? Maybe if we try something and see if we can figure out what this place actually looks like. I'm trying to find it on Google Maps, but it is not exactly working. Let's see here. It's an interesting location. Let's try, I'm going to try searching for photo. And we're going to zoom in here. And we're going to look for where this is. Ooh, I accidentally clicked over there, because that's not where we grabbed it. It's right over here. And then what we can start to do is start to align some of our different data from the world onto where we are to see if we think that it can align with that and what we might be able to find. Looks pretty interesting. Grab a terrain map and look at that. Oh, wow. It is a very intense landscape. All right. The point here is that we have a massively modeled terrain. Now, if we zoom in on this, we can see that there's a bunch of detail there that is not exactly appropriate or what we want. So what I'm going to do is I'm actually going to run through this one more time. And we're going to use a different method of bringing this in. So we're going to use the height field. We're going to bring in that height field map. We're going to go 0, 0 because I moved it. And we are going to use, what was our, we can find it in all of the tabs I have open currently. There it is. 17.28. And let's do 100 by 100 this time. And we are going to make sure the height is set to the max height, which is in this tab here. Move that out of the way. Sadly, our thing refreshed, but our max height is going to be the 33.33. What I'm actually going to do is 33.33. Yep. So that's what we wanted. And we're going to use the mesh. So we're going to create that version. And you'll start to see the difference in the resolution between those two textures. That's the difference between 1,000 points and 100 points. All right. Give me a second. And all right. So we're going to take both of those and we're going to move them over there. And now we're going to do another height field. And we are going to bring in the same one. We are going to do this at 0, 0, 0. We are going to put this at the 17.28 because that is the map size. We are going to use, let's use actually 1,000 by 1,000 again, and the height 3.338, which does align with our 3.338. That might actually needed to be rounded down, but that's all right. And we're going to use surface with control points at sample location. So this is very important because it is surface with control points, not a mesh. We're using a very different way of looking at this thing. This is going to create some complexity to what we're doing. So you can see that the amount of control points, you might have to run the memory and crash. You want to save. And yes, I do want to save my model. I want to save this. I'm going to save this as I already have this file here. I'm going to oversave this on my desktop. And yes, I want to replace it. And while we do this, I'm going to let this run in the background. And we will be right back. All right. We are back. So let's see what happened. So that took just about a minute or so to figure it out. And it looks a bit different. Our model is now far more complex. There's a lot of detail in there. And we can kind of mess around with it and behave differently with it. Now, what I do want to do here is I want to showcase how big this actually is. And to do that, we're going to zoom in on these weirdly represented versions of massive terrains. And we are going to create a person. So I'm gonna make a cone, and I'm gonna say the base of the cone is gonna be, I'm gonna actually disable. So you can see that my Rhino is starting to get a little wonky and not behaving as well as I want it to. So my base of my cone is going to be right about here. And I'm going to go down over there. Oh, actually, that might have been the wrong place to start that command. I think actually my base of my cone needs to start here. Why is my grid snap on? All right, there we go. Cool. Just remember how to create a cone, Peter. All right, end of cone, 10. My cone needs to be, how big is a person in kilometers? Well, let's just do this. Let's see, 5'6", 5'6" inches to kilo meters. Let's see if this works. Oh, that is like so small. See, that's just terrible. This is why it's so big. All right, we're gonna switch our units because that is too large. And we're going to go to feet. Model units change from kilometers to foot. Scale model, no, I don't want to scale the model. I just want to change my units. And over here, we're going to make a cone. And the radius of the cone is going to be about 1.5. Oh, this is bad. What is happening? So this is 17.5 kilometers right now. I just undid a bunch of things. And you can't work at different units at the same time in Rhino, which is very frustrating. So what I need to do is I need to say that I have a line. And that line is going to orthographically be up by that much. We're going to turn our snaps back on, and that equals 0.002 kilometers. And 0.002 kilometers is 5.5 feet. So I want to give us a scale of what we're actually modeling here. So this is a person. This is 5'6". This is like 4 inches taller than I am. And this is the size of the terrain we're modeling. We need to contextualize that. It's huge. It's massive. Right? So understand what we are actually looking at, and understand that any one point here is a very, very specific moment in this. Now, what we can do as I start to wrap this up is we can start to smooth these things out to get a different kind of representation. So very similar to my YouTube video where I look at different representations of the terrain. I'm actually going to, let's see, this, we're going to leave all of these here. We're going to open this up. And we are going to click on this and say smooth. And when we do that, I'm actually going to just jump this up to a large degree of smoothness. Because I want it to just kind of like render out a little bit better. I'm interested in putting something on the site or investigating the site as a massive thing. And this is going to take a little bit of time. This is definitely going to take a bit of time. Oh, there we go. That actually looks pretty good. Now, note that this is the surface This surface is it's a surface, whereas these other ones we created are meshes. They are much easier to handle with computers, but they're never going to be as smooth as the other one there. They do look pretty good from different points of view, though. And if we zoom back in here, now how accurate is this? I don't really know. It's probably not entirely accurate. The other thing you can do with these surfaces is you can rebuild them to get an approximation of the surface. Oh, let's get this going on here. My purple surface is doing some weird things. This is where it just becomes not helpful to do everything in perspective. We're going to undo that. We're going to zoom all extents, and we are going to copy that surface over here, because what I want to demonstrate is how to rebuild a surface and what you can do with the rebuild tool. As we let that generate and complete the function there, what is interesting here is that we are really looking to create a representation, a visual representation of the surface. All right, so we're going to use the rebuild command, and I want to specifically show you rebuild. This is the command, rebuild. Rebuild is a great command, especially when you're using non-mesh based surfaces, which I don't always recommend because mesh-based surfaces are less taxing on your computational hardware than surfaces or control point surfaces. NURBS surfaces, very different kinds of surfaces here, but the difference is it's not a mesh. So the rebuild command only applies, well, mostly only applies to non-mesh surfaces. With the rebuild command, what you're looking at is the amount of divisions between the U and V directions. And what we can do is we can start to establish a difference here. I am going to delete the input. Right now, there are 997 and 997 U and V span counts. And what it's going to do is it's going to create 97 and 97. It's looking at creating these different surfaces. It's going to rebuild it this way. Now, what I want to do is I want to downgrade this. We're going to look at, so no, we don't want that to be unequal. We want it to be like this. Actually, we are going to stay at 100 because I do want to preview it, which the preview will work and kind of result in this rebuilt simplified surface. So there's less data that Rhino is analyzing here. And then what I am going to do is I'm going to calculate the deviation. And this is going to take a little bit of time here to calculate that deviation between what it's doing is it's talking about how far away from the original point certain points are actually being modified. So again, we're not accurately modeling every single point within this entire massive terrain. You saw how big that was. It was only, it's like, for me to be able to walk this terrain is an immense landscape. You can, with the tool that we used, you can come in and start to create different versions of this. The height field maps, the map size, the base level, right? You can control these different things and suggest a smaller area you want to use. But the point is, it's a massive representation. The other point I want to make, as this is calculated in the background, is that with the video I posted previously, which I'm going to pull up here in a second, is that you might want to differentiate the massive terrain that extends beyond your project and the terrain that is specific to your project. Now, that comes down into contours and the way in which you're representing those different things. So the contours that we're probably working with are massive contours. And what I mean is how much space is between the elevations. So there's a level of resolution and accuracy that is not entirely there, compared to when you might be working with a 100-foot by 100-foot site, as opposed to a 17-kilometer by 17-kilometer site. And as we let that calculate out, I'm going to take a moment to find the video I really wanted, or the moment in the video I wanted to show us. And this is this video, which is related. I'm actually extending the video that I have created here. I'm gonna let that load out. Let this continue to load. There we go. So in this part of this video, which is the first mesh terrain representation, what you can see is that I have modeled a single plane that is the size of my site and my building. And then the background is rendered out with the massive terrain. This might be representative of, this might just be used as a background, as some kind of like, oh, look at what that is. And, or it might be used to fly around things within a virtual reality space, where you can actually kind of massively occupy something and see what the context is. So a lot of sites also, when you download these models, will appear incredibly dull and incredibly not important. You will see very slight height differences, and therefore it's not necessarily worth going through this whole thing. I've specifically chosen points both in this video here, this is a part of Alaska, and in the other, in what I'm doing in Rhino, which we'll jump back to here. We do get some data back on this. 0.08 maximum deviation. But the point is here that these work a lot better for sites that have large differentials in terrain. Rhino has given me a large amount of information on where it found points that are differentiated from the beginning and the end. I'm going to hit OK and let it just complete that. And then we can start to see that that looks a lot better in terms of what this area might actually look like. Let's isolate that, and let's just grab a shaded. Now let's render that. And also remember that we are incredibly small in this. We might be approximately at somewhere around this size. Set view, we're going to turn walk mode on. Oh, that's not what I wanted. There we go. This might give us a somewhat of a approximation of how this landscape would feel. The next thing we'll probably do is try to see what happens if we drop this into Twinmotion and see if we can make it work as a real-time rendering terrain. But for now, we'll end it there. Thanks, everyone, and enjoy.